Good morning. Today we are discussing about analytic functions. Let us start. A function f of the complex variable z is said to be analytic at a point z0 if it has a derivative at each point in some neighborhood of z0. That means take a point z0 and take some neighborhood of z0. Then f is differentiable at each point in this neighborhood of z0. Then we say that f is analytic at z0. Okay. Note that if f is analytic at a point z0, it must be analytic at each point in some neighborhood of z0. Okay. A function f is analytic in an open set if it has a derivative everywhere in that set. That means if you take an open set, if f is differentiable every point in that open set, then we say that f is analytic in that open set. Okay. Consider the example f of z equal to 1 by z. We know that f of z is not differentiable at z equal to 0. Okay. So f of z is analytic at each non-zero point in the finite complex plane. Here f of z equal to 1 by z is not analytic at z equal to 0 since it is not differentiable at z equal to 0. Okay, but the function f of z equal to mod z square is not analytic at any point since its derivative exists only at z equal to 0. Okay, next, entire function. An entire function is a function that is analytic at each point in the entire finite complex plane. Example, polynomials. Since the derivative of the polynomial exists everywhere, it follows that every polynomial is an entire function. Similarly, e raised to z, sin z, cos z are entire functions. Okay, if a function f fails to be analytic at a point z0, but it is analytic at some point in every neighborhood of z0, then z0 is called a singular point or singularity of f. Consider the example f of z equal to 1 by z. We know that here z equal to 0, here at z equal to 0, f is not analytic. So at z equal to 0, so z equal to 0 is a singular point. Whereas the function f of z equal to mod z square, it has no singular point since it has nowhere analytic. Okay, thank you.